In this video, we're going to talk about segment proofs, so proofs of a line segment. All right, use the segment addition postulate to write 3 equations using the diagram below. So the segment addition postulate is just saying that I could take part of a line segment and put it with another part of a line segment, and then I can say that from here to here is equal to this piece to this piece. So let's look at what that looks like. So if I took PQ plus QT, that would give me PT. So PQ, let me go back to that one. PQ would be here, and then QT would be here. Well, sort of here. So that would be everything from P to T. On the next one, QS plus ST would be everything from Q to T. And then on this last one, PS plus ST would be equal to PT. So PS plus ST equals PT. All right, so our proof. Given that X is the midpoint of WY and that WX is congruent to XZ, prove that line segment XY is congruent to line segment XZ. Okay, so they said X is the midpoint of WY. We knew that. It was a given. So if X is the midpoint of WY, then that means that WX is the same size as XY. All right, so that's what I can say here. WX is equal to XY by the definition of a midpoint. Okay, I could also say that line segment WX is congruent to line segment XZ. Okay, that was given to me. So line segment WX is congruent to XZ, the one going perpendicular up and down. So those are the same size. I put 1 tick mark on it because it's the same size as the other 2 pieces that have 1 tick mark. And I knew that because it was given. Now I can write it without the line segment bar over it, and instead of congruent, I can write equals. Okay, that's what the definition of congruence means, that line segment XY is congruent to line segment XZ is the same as saying the size of XY is equal to the size of XZ. Now I can take XY and I could set it equal to XZ by substitution. So if I look at the step above, I had WX equals XZ, but I know that WX is the same, it's equal to XY, so I can substitute in XY where I had WX. So I substituted WX equals XZ, or XY, and so now I can write it line segment XY is congruent to line segment XZ. All I added was a congruent symbol instead of an equals and the line segment bars, and I said that is because definition of congruence. All right, in this one, I was given that line segment AB is congruent to line segment CD, and I want to prove that line segment AC is congruent to line segment BD. All right, so AB is congruent to CD. That was given. I'm going to draw my tick marks on my line segments. And I can write it without the line segment bars, and the congruence can just become an equals by definition of congruence. And then I can say that AC, so from A all the way to C, plus CD is equal to A all the way to D. Okay, that's by the segment addition postulate. And then I can also say that AB plus BD is equal to AD. So it's just another way of writing the same thing, segment addition postulate. Now I can take CD plus BD, because CD is the same size as AB. I substituted that AB is equal to CD. So I took the step I had above and I plugged in a part. Now the transitive property is the next step. I had AC plus CD equals CD plus BD. I had 2 different things that equaled AD, so I set them equal to each other. They both equaled the same thing, so I can set them equal to each other. That's the transitive property. Then I got rid of CD, so that's the subtraction property. I just subtracted that out. And I was left with AC equals BD. Now I can write them as congruent line segments by the definition of congruence.